But it's about time to start, so I will just go ahead and start. If you miss the first few minutes, you can just go back and watch the recording. So there is a midterm coming up tomorrow, and to be exact, it's in 23 minutes. If you're watching the recording, you have less than 23, sorry, not 23 minutes. Clarify you, it's 23 hours. If you're watching the recording, it's less than 23 hours. But don't worry, today I'm going to cover a lot of different things that you will see tomorrow. So you will do the questions while we have a strong memory. So let me just go ahead and share my screen, and I would like to talk about the arrangement of the midterm first. So can everyone see my screen?
Yep. Okay.
So about the first midterm, it's going to happen at 8:30 a.m. tomorrow morning Pacific time. If you are in a different time zone, just check the clock and make sure that you don't miss it. We don't accommodate late, and I don't see anyone of you to take the early. So I would say just show up and go to Canvas, just join the prompt meeting. And tomorrow you do have to turn on your camera. So right now you don't have to do that, but tomorrow, because we want to proctor you, you have to turn on your camera and mute yourself. You can't mute your microphone so that we don't hear you, but we want to see you. And I won't mute myself, and you don't have to mute your speaker so that you can hear me. So if there's anything I will just talk and maybe just if we have the chat function. But hopefully not, okay, because we've been checking the exam questions to make sure that there is no confusion. You do have some clarifying question to ask during the exam, just feel free to ask. And the length of the exam will be 80 minutes, and we recommend you to just use 60 minutes to finish the questions, and then the remaining minutes to upload the answers because it can take time. The total points for the first exam is 60 points. So you can approximately 1 minute for 1 point. So if the question is worth 9 points, then you should just use 9 minutes to finish it. Okay, that would be the recommendation. And you will have to use Canvas to submit your answers, and you have to join a meeting so that we can see you during the exam. Okay, and the coverage of the first exam will be the textbook chapters 1 to 3, the lecture recordings 1 to 6, and then TA sessions 1 to 3. And if you look at the TA notes, there are actually 4 TA notes. There is a TA session 0 for the math review. So those will be what you need to rate before the exam or during the exam if you want to. So that would be the logistics of the first exam. Any question about the exam?
I actually have a question.
Okay, please ask.
Yeah, so I'm seeing here at the bottom of the slide, we're talking about how to determine if the solution is either corner or interior.
Yeah, I will talk about that. I will talk about that later.
Yeah, but my clarifying question is that going to be on the exam?
No.
Okay.
We will not test corner solution in the exam. So that's what I'm going to talk about. So even though I'm going to give you the information today, because some of you are confused about the second question in the first version of the practice midterm. But we actually don't want to test you on that. So you can just feel relaxed, okay? All right, so let me just start today's session. Any other question?
Yes, I have a request. Would we be all able to turn off our mics? I'm sorry, it's very hard to hear you.
Oh, you can't hear me? Or I actually already turned on my mic. Have you tried to increase
But can the other students turn off their mics? I'm hearing like other.
I see. Yeah, so everyone please just mute your mic so that we don't hear the noises and so other students can just hear me right now. All right? Okay. Great, let me talk about today's plan. So we will finish TA session 2 and TA session 3. So as you can see, last time we didn't finish all the materials in TA session 2. And so we will actually go back to that TA note and then talk about the remaining issues. And then we will talk about TA session 3, including 4 different types of utility functions. And specifically, the most important utility functions that you need to know right now are the Cobb-Douglas utility function and the perfect complements. For perfect substitutes and quasi-linear utility, because they involve corner solutions, and as I said, we won't test you on corner solutions, so you can just feel free to skip them. Just focus on the first 2 types of the utility functions for now. Let me go ahead and talk about corner and interior solution first. So firstly, you need to know what is corner and what is interior. If you look at a budget line, so we know that an optimal solution will be on the budget line because you will exhaust your budget. If you have any money left in your pocket, you will just go ahead and spend it. You won't save any money because that won't generate any utility according to our setting. Our setting tells us that your happiness or your utility solely depends on how much you consume, right? And the more you consume, the happier you are. So you will definitely spend all of your money. So that's why we know that your optimal consumption will be on your budget line. And then which point are we talking about? So if it is the blue point, then it is one of the corner solutions. If it is the green point, the lower one, then it's another corner solution. But it is in between these 2 points. For example, the pink one, then it's an interior solution. So formally, an interior solution is when both of your consumption levels are positive. And a corner solution means one of your consumption levels is 0. So you will just buy one of the goods, but not all of them, okay? Because we are only talking about 2 goods. If we are talking about more goods, then the definition, it looks actually more complicated, but we will just focus on 2 goods. And then how to check if the final solution should be one of the corners or interior. We will go back to that when we talk about each utility function. And then I would like to talk about utility maximization, its general form. So basically, the consumer theory is dealing with how to maximize the utility, the happiness of the consumers by choosing the right consumption levels subject to a budget constraint. And here in this utility maximization problem, you can see that our objective is to maximize the utility, right? By choosing X and Y. So X and Y are 2 consumption levels. they are the consumption levels of good X and good Y. They can be apple, they can be orange, they can be anything. We just randomly pick 2 goods, or we can combine some goods as X and combine the rest of the goods as Y. And we are talking about these 2 types of goods. Those are all possible. But here we just want to be abstract as possible, as general as possible. And then for good X, the price is P sub X. For good Y, the price is P sub Y. And your income, let's denote your income as I, okay?
Oh, a question.
Please ask.
Is that equals sign the right direction? Would you?
This is not equal sign. We will talk about this. It's actually greater or equal.
But yeah, could that? But isn't it pointed the wrong way? Because couldn't if PX and PY are greater than your income?
You are right.
That's all I was wondering. Okay.
Yeah, you are very correct. It should be, that's a typo. It should be this. Yeah, because how much you spend cannot exceed how much you have, right? We don't have borrowing or lending here, so you can just exhaust your budget at most, or you do not spend all your money. That's right. So that will be your constraint, and this will be your objective. You want to maximize it, but you also have to satisfy this constraint. And how to do that? We talk about constraint optimization very early this quarter. We talk about the Lagrangian method, right? So we just write the Lagrangian. The Lagrangian will be equal to your objective plus a Lagrange multiplier lambda multiplied by your constraint. And we use the right-hand side to subtract the left-hand side because the right-hand side is larger, right? So it's I minus P sub X times X minus PY times Y. And this is our Lagrangian. By doing so, we convert the constraint optimization to an unconstrained optimization by considering both simultaneously in one objective. So our new objective is the Lagrangian. And then the next step, since it's unconstrained optimization now, we just take the derivative of our objective with respect to all the choice variables. And here, the choice variables are X and Y. You have to choose them, right? And you have one more choice variable, which is lambda. That's the new variable that you introduce to the system. So we take the first derivative of the Lagrangian with respect to X, with respect to Y, and with respect to lambda, and then we set them to 0. That will be the first order conditions. And the derivative of the Lagrangian with respect to X is equal to the marginal utility of X. Okay, because you take the derivative of U with respect to X, then you will get U sub X. And here you also have X in the constraint. So when you take the derivative of the second part of the Lagrangian with respect to X, so I and PYY are irrelevant. So you can ignore them. And here negative PX times X has X in it. So when you take the derivative, you are left with negative PX. And you also have lambda outside the parenthesis. So that's why you are left with negative lambda times PX. And then this is equal to 0. You can rearrange it, and then you will get lambda equals the marginal utility of X divided by the price of X. And similarly, you will get lambda is also equal to the marginal utility of Y divided by the price of Y. Since they are both lambda, they are equal. So you can get this marginal utility of X divided by the price of X equals marginal utility of Y divided by the price of Y. This is exactly the equal marginal utility per dollar spent rule that you learned in 200. and they are both equal to lambda. Or you can kind of rearrange it, and then it becomes the ratio of the marginal utilities is equal to the ratio of the prices, right? These two are equivalent. It's just a simple rearrangement. So that's what we get from the first two first order conditions. And finally, we have one more first order condition, which is the derivative of the Lagrangian with respect to lambda. And you set it to 0. When you take derivative of the Lagrangian with respect to lambda, you are just getting this constraint. And when you set it to 0, it's equivalent to say that the budget constraint is binding, which means you take the equality sign and you get rid of the inequality. So we know that even though in our problem, the constraint is an inequality constraint, but eventually it's an equality constraint because you know that eventually you will exhaust your budget. So how much you spend will be exactly equal to how much you have.
Oh, sorry. Before we go on further, do you mind if I ask another question?
Yeah, please ask.
Okay, so so U sub x is that marginal utility?
Yes, that's the subscript notation we talk about in math review. So
Yeah.
when you have a subscript, then it's saying it's the first partial derivative with respect to that subscript. So it's the marginal utility of U with respect to.
So U sub x is how much is it one extra unit of x, how much that increases U?
Yes, but you have to think about it at the margin. It's not just 1 unit, it's a very small change of x.
Yeah, but it's like it's essentially, it is, that's what it is, right?
Yes.
So,
right.
so U sub x over px is like how much a dollar changes utility?
Yeah, how much a dollar spent in good x can give you in terms of utility.
Okay, so ux is how much increasing x increases u,
yes.
And ux over px is how much increasing px increases u. Ux.
It's not increase in the px, it's like how much you spend in x. So previously u sub x is like how much you consume. It's in terms of the unit of x, but we want to convert it to dollars. So how much each dollar you spend in good x can bring you in terms of utility.
Yeah, okay. That makes a lot of sense. Thank you.
Yeah, that's exactly the things that we talked about in 200, but I know some of you didn't take it and maybe some of you forget about this part, but that's why I want to remind you that they are actually kind of related. And so once you do that, you have equation 3. You also have this equation 1 plus 2. So from equation 1 and 2, you get this equation. You can forget about the lambda here. So in this equation, you have two unknown variables, x and y. Okay, px, py are regarded as parameters and they are given. Usually we will tell you what's the price is. And then income is also given as a parameter. So in this equation 3, you also have two unknown variables. So with these two equations and two unknown variables, you will be able to solve for x star and y star. And finally, once you have solved x star and y star, you can continue to calculate lambda star. So it's the optimal lambda. So you can use either 1 or 2 to get lambda. So you can see that in the practice exam, question 2, the version 1, I actually used the second equation to get the lambda, which is the u sub y over py. But you can also use u sub x over px. And let's firstly recall what lambda is. So recall that we talked about the meaning of lambda in a general optimization problem. it's the increase in the objective when the constraint is relaxed at the margin, right? But putting it into this specific setting, we will know that lambda is actually the increase in utility, okay, when your income is relaxed at the margin, which means when you have $1 more, how much more utility you can get. So that's exactly the marginal utility of income, okay, or marginal utility of wealth. So that's how this term is coming. And then how to calculate it, use either 1 or 2. And here I use the second equation, equation 2. So lambda star is equal to the marginal utility of y divided by the price of y. But when you calculate the marginal utility of y, you need to use the optimal values of x and y, right? All right, so let me give you a specific example by going back to TA note 2. So this is the example that I gave you in the TA notes. The utility function is 5 times log x plus 2 times log y. This looks weird, but I will tell you it's equivalent to Cobb-Douglas. It's a monotonic transformation of a Cobb-Douglas utility function. Basically, you take a natural log of the original utility function. Okay, recall how we convert exponential to, multiplication to summation, and then exponential to the coefficient of natural log. And then we have some constraints. We have budget constraint. So here we use W to denote your income or wealth. And the right-hand side will just be how much you spend. That will be your expenditure. We actually call it expenditure function later. And we also have 2 non-negativity constraints. You cannot consume a negative amount. So you can either consume 0 or a positive amount. So firstly, we need to see if this utility function can have corner solution, which means can either x be 0 or y be 0. So it seems that x and y cannot be 0, just according to the natural log, right? So mathematically, it's already constrained by this natural log. We know that we don't have natural log of 0, so they cannot be 0. So we already exclude the possibility of corner solution, so we just don't need to worry about corner solution for this question. And then the last two constraints will be slack because they will never take the equality sign. So x and y are both positive, so you can basically forget about the last 2 constraints. The last 2 non-negative constraints will be dropped. And then this constraint will be binding according to our discussion earlier. The reason is the utility function is increasing in the consumption level. So when you consume more, you get more utility. And due to the fact that the utility is increasing in your consumption only, so when you have money, you will just go ahead to buy more. So eventually, you will have no money left in your pocket. So it will be binding. So we replace the inequality by equality. All right. And then this will be our simplified utility maximization problem, and the Lagrangian will be your utility function plus lambda times the budget constraint. And then the procedure is the same as before. And here lambda should be positive. It's the marginal utility of income, right? And it serves as a punisher of the violation of the constraint. And that's what we talked about before in the math review. And now we can just maximize the Lagrangian. So we just take the first derivatives of the Lagrangian with respect to each each choice variable. And we can kind of rearrange the first 2 equations and then combine them to get this ratio of marginal utilities equal to the ratio of the prices. And then the last equation is the budget equation. And then we can use these two equations with two unknowns to solve for X and Y. So I will not go through the details about how to calculate them. I think I will already provide these completed slides with you. So some of you might have already gone through the calculations by themselves. And here, what I want to talk about is two more methods to solve for utility maximization without involving the Lagrangian. So the first method is the substitution method. It's also discussed in the textbook. Basically, what we want is to reduce the number of unknown variables, the number of choice variables, using the budget equation. Since we know that the budget constraint will be binding, we have an equation about X and Y. Why not express Y as a function of X and then replace that Y in your objective so that you only have X? So that's what we are doing here. So you can see that we still have 5 times log X, but then we don't have 2 times log Y because Y is now replaced by the budget equation. Basically, you express Y as a function of X and your income, and then you plug it into your objective function. So that now you are left with only one variable to choose, and you don't have a constraint. So this is another way to convert a constraint optimization problem to an unconstrained optimization problem. And then you just solve it by taking the partial derivative. Actually not partial anymore, there's only one variable. So just by taking the derivative with respect to X and set it to 0. And once you get the optimal value of X, just plug in the X into the expression for Y, and then you get Y as well. And you don't have lambda, you don't have Lagrangian. So that will be a second way to solve it. And a third way is the graphical method. So what's the graphical method is telling us? So previously I showed you that the optimal solution can only be on the budget line, right? So it will definitely be point C, point E, or point A here. But which point exactly? We need to also introduce the indifference curve. So indifference curve is telling us all the combinations of the consumption bundle of the consumption goods that you can have to generate a certain utility. For example, for indifference curve 1, so the I1 is the indifference curve 1. Sorry, I have to move my dialogue a little bit so that it's not blocking my view. Okay, so let's talk about indifference curve 1. So indifference curve 1 tells us that point A, point D, point C, and point G will give you the same utility level. So basically, you can achieve a certain utility level by consuming different combinations of the two goods, Q1 and Q2, good 1 and good 2. And here in this example, it's pizzas and burritos. And indifference curve 2 will also give you all the possible combinations of bundle that will give you another utility level. And one more thing about the indifference curves is that the higher the indifference curve, the higher the utility level. So the direction of increasing utility is moving from the origin to the right or above. So here indifference curve 2 gives you a higher utility than indifference curve 1, and indifference curve 3 will give you a higher utility than indifference curve 2 and 1. So understanding this, what is left for us to do is just to move the indifference curve up and down and find the one that is the highest. because we want to maximize our utility. So we want to find the highest possible indifference curve that can be supported by your budget. And that is exactly the indifference curve 2. So you can see that you cannot move indifference curve 2 outward any further. If you continue to move indifference curve 2 toward indifference curve 3, then you do not have a support, because all the consumption levels, all the consumption bundles will be too expensive to you. Your budget is below the budget line, and you want to achieve something that can only support it by, a higher budget, and that's not possible, right? So eventually you want to find an indifference curve that is tangent to the budget line, and that will be the highest possible indifference curve that you can find, which is also supported by your budget. And notice that when they are tangent to each other, okay, at point E, they have the same slope. That's what tangency is telling us. So this point E, which is the optimal consumption bundle, is telling us that at this point, the slope of the indifference curve is equal to the slope of the budget line. Okay. And to talk about this, I would like to go back to my iPad and talk about marginal rate of substitution first. I know the professor already talked about marginal rate of substitution, but we need some clarification because I think the professor is using a different definition from the textbook. So in the textbook, marginal rate of substitution is the slope of the indifference curve. And the marginal rate of transformation is the slope of the budget line. And to calculate the slope, okay, just use dy over dx. And y is the vertical axis, x is the horizontal axis. So that's how we calculate slope, right? But the professor took an absolute value of the slope because we know that the slopes are negative because all of them are downward sloping. If we are just interested in the magnitude, we take an absolute value, and this is achieved by adding a negative sign. So when you add a negative sign to a negative number, it becomes the positive. Due to the different definitions used in this course, we won't care about which definition you are using, as long as it's consistent throughout your answer. You can always use the textbook version, or you can stick to the professor's version, as long as it's consistent throughout all your answers. Because it's just a negative sign. They will cancel out each other later. But how to calculate the slope? One way to do it is to get an expression of y as a function of x, and then take a derivative. Another way is to use the implicit function theorem we talked about in the math review. I would like to use the implicit function theorem. So, because marginal rate of substitution, dy over dx, is the slope of the indifference curve. And the indifference curve is fixing the utility at a certain value. So it's saying that we are fixing the utility function to a constant. And then what will happen is that x and y will become implicit functions of each other. And then we will just apply the implicit function theorem to get dy over dx, which is the ratio of the partial derivative of the function with respect to each variable with a negative sign. So this will be the formula. And know that u sub x is the partial derivative of the utility function with respect to x, which is the marginal utility of x. And for the budget line, we can also apply the implicit function theorem by treating how much you spend as a function. We call it expenditure function, and we are fixing your expenditure function to a constant, which is your income. And then we apply the implicit function theorem. So the slope will be negative of e sub x over e sub y. And e sub x is the partial derivative of your expenditure with respect to x. And when you take a partial derivative of your expenditure with respect to x, you are left with just the price of x. So that's why eventually the slope of the budget line is the price ratio. It's from the implicit function theorem. So understanding this, let's go back to this graph and this equation. So the third method to solve a utility maximization problem is by equating the slope of the indifference curve, which is marginal rate of substitution, with the slope of the budget line, which is the marginal rate of transformation. So it's saying that we should equate the ratio of marginal utilities with the price ratio. And this is exactly the equation that we get from the first two first order conditions when we use the Lagrangian method, right? With the Lagrangian method, we have three first order conditions, and we use the first two first order conditions to get this equation. But why not get this equation right away without writing out the Lagrangian? So that would be the point. The point is you can write out this equation without doing Lagrangian.
A clarifying question before we continue.
Okay.
I'm just a bit confused with the notation of mu. Does that stand for u of x over p of x?
Mux is equivalent to u sub x. I'm just adding the m to denote it's marginal.
Okay,
So
okay, that's a
forget about m. Yeah, m is marginal.
And so m of ux, sorry, mux is equal to ux. All right.
Yes. Yeah. So the m is redundant here. It's saying that you should know that it's a marginal utility, so it's a derivative.
So you can find those by taking the derivative of the original equation with respect to x. You don't even need to you don't even need to have the lambda in there at all because you're not using Lagrangian. It's just like, for example, we were using that 5 ln x.
Yeah, even with the Lagrangian, we don't use the lambda there. We only focus on like this equality, but not the equality with the lambda. So
all right, yeah,
no worry about this.
Do you think we could do some like a quick example of one of those two examples?
Yeah, we will use this method to analyze the 4 different types of utility functions in the TA node 3. All right, so now we are done with TA node 2. Let me go ahead and talk about 4 different types of utility functions in this class that you need to know. The first one is Cobb-Douglas. So what is Cobb-Douglas? So this is an example revised from an old midterm question in winter 2007. So this is a Cobb-Douglas utility function. It's x to the power of 0.3 times y to the power of 0.7. And you can know that the summation of the exponents is equal to 1. So this is a typical Cobb-Douglas function. It can be 0.3, 0.7, 0.4, 0.6, or 0.5, 0.5. So the general form would be x to the power of alpha times y to the power of 1 minus alpha. Okay, that would be the general form. But here I'm giving you a specific example. So firstly, we need to discuss if the solution is interior or corner. And as I said, for Cobb-Douglas function, we don't have corner solution. Here are a few ways to verify that. The first one is by simply thinking about what will happen if one of them is 0. So if one of them is 0, by looking at this equation, because it's multiplication, so when one of them is 0, the utility is 0, right? It doesn't make sense. You get 0 utility. But if you consume any positive amounts of both, then you instantly get a positive utility. So 0 can never be the solution, right? So that's one way to quickly eliminate the possibility of corner solution. Another way, which is slightly more complicated, is to calculate the marginal utility. If you calculate the marginal utility of x, it's taking the partial derivative for u with respect to x, and then you plug in x equals 0 into the marginal utility and see what happens. It will become infinity. And it doesn't make sense as well. Because when you have an infinite marginal utility, it instantly means that you should consume that good, because it gives you, if you start to consume it, it gives you infinitely amount of happiness, and why not do so? So that will be another way, but as I said, corner solution is not important in the exam. So you just need to know that Cobb-Douglas function cannot give you a corner solution, and that's all. So when you solve a utility maximization problem with a Cobb-Douglas utility function, just never worry about corner solution.
I have a quick question for that.
Please.
So how do you know, how is it equal to infinity? Because when you do the derivative, like the x is like negative power. So how is that?
Because it's negative power, so it becomes the denominator, right? So if you write it as a ratio of two numbers to the positive power, then you will see that because it's in the denominator. So when it's 0 and when the numerator is positive, it approaches to positive infinity. Yeah, that wouldn't be the main concern here. So you can just use this simple way by plugging in 0 into the objective function and see what will happen to the utility. And because the utility will be 0, it won't make sense to have any of them being 0, right?
So does infinity count as a corner, or is it only 0?
So when you calculate the marginal utility and when you plug in 0 into the marginal utility function, you get infinity, which is saying that if you start to consume just a little bit of x from 0, then you get a lot of utility from it. And so that couldn't be your solution, right? Because if that is the solution, you cannot improve your utility anymore because it's already optimal. Yeah.
No, yeah, that makes sense. Okay.
So let's practice the graphical method without the Lagrangian. So I will recommend you to do that because that saves you a lot of time. Just write this out. So what's the marginal utility of x? So this is what I'm talking about. When you take the partial derivative of u with respect to x, so you subtract 1 from the 0.3, then it becomes negative 0.7. And put it in the denominator. And of course, you have to take down the 0.3 from the exponent, right? And that will be your expression for mux or ux. And for u sub y, it's 0.7 times x to the power 0.3 divided by y to the power 0.3. So from these two expressions, we know that neither x or y can be 0 because they are in the denominator. And then you just equate the ratio of the utilities, marginal utilities, with the ratio of the prices, and then you get one equation. So from this equation, you can get this expression. You can express, so it's cross multiplication. So you will get py times y equals 0.7 times x times px divided by this 0.3 here. I will not go through the calculations. I will just provide these slides to you so that you can do the calculations by yourself. And then combine this equation from this MRS equals MRT with the budget equation. So this is the budget equation with PY times Y replaced by this expression equals your income. we will be able to get X and then Y. So do the calculations by yourself later, not in the class, okay? And a few things that I want to mention about this Cobb-Douglas is that the 0.3 and 0.7 actually represent the relative importance of the two goods. So from this utility function, we can say that Y is more important to you compared to X. And because of that, when you go back to your solution, you notice that you spend more on Y. You spend 70% of your income to buy Y, and only 30% of your income to buy X. So that will be the feature of the solution. As long as you know the exponents, you instantly know what the solutions will be, even though you do all these calculations. But eventually you can check if your answers make sense, if you are spending more on the more important goods to you.
And conceptually, that just means that X in this case has a higher price compared to its utility, so we should be consuming more Y, right?
It's not how much you consume is not about the price. So here it's about how to allocate your income to different goods. So you're allocating 70% of your income regardless of how expensive the Y is. When you allocate 70% of your income to consuming Y, if Y is very expensive, you can only buy little Y, right? But when Y is very cheap, you buy a lot of Y. So allocating the income to different goods is not about the price of the goods, but eventually how much you can buy depends on your, it depends on the prices. All right, the next important utility function that I need to talk about before we end this TA session is the perfect complements. To talk about perfect complements, I would like to use my iPad to show you an example. So imagine that you always consume X and Y in a portion of 2 to 1. So the question is, what is your utility function? So let's say X is the beef patties and Y is the bun. So you always need 2 beef patties with 1 bun, okay? You refuse to have only 1 patty. If you only have 1 patty, you cannot make a hamburger. You need 2. So that's just you, right? So we are talking about this specific case and what's the utility function for this specific case. So you can clearly see that they are perfect complements because they should be consumed together. You cannot consume either one individually, right? And because you have to consume them in the portion of 2 to 1, then it's saying that X is equal to 2Y. So for example, if you have 4 beef patties, you need 2 buns, right? So if Y is equal to 2, Y is the number of buns, then you need 4 patties. So it's vice versa. But let's think about a case when you only have 1 bun, but you have 4 patties. What will happen? You have 2 extra patties that cannot go into a hamburger. So the 2 extra beef patties are redundant to you. You need 1 bun to make it complete, to enjoy it. But if you only have the 2 extra patties, they are like redundant and unnecessary. Your utility still depends on only the 1 hamburger that you can make. So because of that, your utility is limited by the 1 that is fewer than what the proportion asks for. So we use the one that falls off the proportion to determine your utility. That's why your utility function is the minimum of x and 2y. We know x is equal to 2y, but if any one falls off the proportion, the extra will be redundant. So we only use the one that falls off the proportion to determine your utility. So that's why for perfect complement, the utility function looks different. And I will tell you that this utility function is not differentiable. You cannot take a derivative. Then what should we do? That will be the last content of this theory session. We may go a little bit over time, so if you have things to do, you can just leave, or you can watch the recording later. So, because the utility function is not differentiable, instead of taking the derivative, we just write out the proportion. So in this example, I think in this example, the utility function is x and y, which means the minimum of x and y, which means you consume the two goods in the proportion of 1 to 1. So when you buy 1x, you have to have 1y. So I was giving you a different proportion, and here this is just 1 to 1. You can have another proportion, which we'll talk about later. So you just write out the proportion. X should be equal to y. And this equation is telling you that you should consume at the right angle, the vertex of the right angle. Specifically this point, A, B, and C. So how much you consume should only be determined by point A, point B, or point C. You should always consume in the fixed proportion requested by the utility function. And why is that? So let's take indifference curve 2 as an example. If you consume, say, 3 ice cream scoops, but only 2 pie, then you have 1 extra scoop of ice cream that does not give you any utility. That's redundant, right? And that will cost you more without giving you more utility, and that's not efficient. So let's reduce the number of scoops of ice cream to here. And similarly, you don't want to have extra pie. So they give you the same utility, but they cost more. So that's why you should always consume at the vertex of the right angle. So this is also how we get the indifference curve. And as you can see, they are not differentiable. It's a right angle. It's not smooth. When you take derivative, you just don't know what it should be. So that's why we replace the MRS equals MRT by the fixed proportion equation. We don't have MRS anymore because the utility is not differentiable. We don't have marginal utility. We still have MRT, but we cannot make MRS equals MRT now. Then we replace that equation by the fixed proportion equation, x equals y in this example, and we still have one equation about the 2 unknown variables. And the other equation is the budget equation. So we combine these 2 equations to get to optimal consumption levels. So when x and y are equal, replace, for example, y by x, and then they're both equal to your income divided by the summation of the 2 prices. One more thing before I let you go, which is, what if we have this utility function? How to draw the indifference map? For this one, by looking at the utility function, you should know that it should be 3x equals 7y. So if 3x equals 7y, then x to y will be 7 to 3, right? So you should consume x and y in a fixed proportion of 7 to 3 by equating 3x with 7y. So this is 3x equals 7y. And the vertex should be on this line. So this vertex should be on this line. And then you can draw a few more of these right angle. And then you have an indifference map.
So can I ask a question? So the 3x and 7y is basically just the x star and y star which is the solution of the Lagrangian. It's just you don't need to do any of that because it's already provided.
We don't have Lagrangian anymore because it's not differentiable. So,
yeah, so that's
having Lagrangian means that you have to be able to take a derivative. So for this perfect complements case, you don't have Lagrangian method and you don't have MRS equals MRT. You just replace that by the fixed proportion equation.
Okay, thank you.
So that would be all for today's TA session, I guess. Is it the end of, is it the time to end this, right? So we still have perfect substitutes and quasi-linear utility functions left to be discussed in the future, maybe. But as I said, they will not be included in the first exam. So you don't even need to, read the remaining materials in this TA note. We will specifically focusing on the Cobb-Douglas function and at most perfect complements.
So what you're saying is that perfect complements could be on the test?
Yeah, it could be.
Okay. All right. If it's not too much to ask, because we kind of left off a little abruptly on that perfect complements example that you were just on.
Mm-hmm.
Could I ask one last clarifying question?
Yeah, it's Q&A session now. So after class now, so feel free to leave if you have things to do, and feel free to stay and ask questions if you want. So please ask your question.
Yeah, can we go back to slide 9 first? That was the one that we were just on, I think.
Which one?
Slide 9. You're on slide 8 right now.
Okay.
Oh, there you go. Yeah. So we have this line here, right, which is 3x is equal to 7y.
Mm-hmm.
Could you make that like, what would we do from here? Do we want to set px times x plus py times y equal to the 3x 7y?
No, we just have 3x equals 7y. That's one condition for your optimal solution.
Okay.
So you consume x and y in the fixed proportion of 7 to 3. So x divided by y should be 7 divided by 3. So that's one condition. Another condition is that it should be on the budget line. So you can see that this line, the intersection of this line and the budget line will give you the optimal solution. So this is the optimal solution.
Okay, but you'd probably want a numerical answer, correct, on the test?
That would be the numerical answer. So if you know what the price is, oh, you mean how to get x and y, right?
Yeah, because we kind of set it up, and I see how it equates, but I don't know
it's still not x star and y star yet because there are still two equations which are not. So to solve it, maybe divide both sides by 3. So x is equal to 7y over 3. And then replace the x by 7y over 3 here so that you can get y. And once you get y, you can get x.
Yeah, and px and py would be known in a test question, they tell us, right?
Yeah, I think mostly they will tell you what the prices are. For example, the price of x can be $1 and price of y can be $2. And I can be, for example, $24. If they do not tell you what the values are, just leave them as parameters. So your final answer should be a function of the prices and income. But I would say for the first exam, they mostly will give you the numbers.
Okay. So yeah. And this is the extent of the perfect complements question. It's identifying that linear line, the 3x equals 7y, which is dependent on the relationship between the two goods.
Yeah.
So
It
for every
depends on what
7x, you
want
want
to do.
7y.
Yeah.
And then lining up the budget line, plugging in I, plugging in px, plugging in py, and then
Yes.
from there you should be able to find the true values of x and y.
Yeah, you will get a numeric answer of x and y.
Okay, if
Instead of,
that's all there is to it, I think I understand. Thank you for explaining it.
and actually, perfect complements, I would say, is much easier than Cobb-Douglas because
Yeah.
you don't even need to bother taking the derivative.
Yeah, this is much closer to algebra than it is calculus. It is a bit simpler. Because I looked through the notes last night, and without your explanation, I just saw minimum and I just immediately gave up. It's like I don't know how you even do that. So thank you. I appreciate the explanation.
Okay, great. Any other question?
Yeah, I just had a quick question.
Who is asking?
Anthony.
Okay.
So I was just wondering, is the exam open? No, because I think I saw that somewhere, but I just wanted to clarify.
It's open notes, open book. You can use the internet, but no communication between students.
Okay, great.
Yeah, that's all we ask.
Um,
We rely on everything, but just not other people.
Okay.
I have a question.
Mhm.
Do you think that the homework questions and like the questions that the book generates are a good way to study for the test? Like, do you think that will be like?
I wouldn't say they are very good for, like, I mean, some of them might, but I would say it would be more efficient if you use the example questions that I provide. And the homework questions, I think they tend to be either too easy or either strange in a way that it's kind of like in a different format than what we usually do in class. They're like multiple choice, right? Multiple choice questions, conceptual questions, and fill in the blank, but we want you to have calculation steps. So I wouldn't say homework questions will be a good resource for you to prepare for the exam. Just use the practice exam questions first.
Well, okay, so I wasn't not necessarily the homework questions, but like the book will generate like a study plan.
Those they are, because we don't ask you to do, so I don't think they are necessary. You don't need to do all of them.
But so you think it's better to study from the TA slides then?
Yes. I think the exam questions are more similar to the questions that I discussed.
Yeah. Oh, if I can actually add something to this, like a kind of question that's relevant to this. So I looked through both of the practice exams, and I felt like the second one was a lot more understandable than the first one. Like, because I remember I reached out to you and like was like half of question 2 and question 3 are both materials that won't be on this exam.
Yeah, that's right. Yeah, so, I realized that the first one is more like in the past when we only have one midterm instead of 2. So kind of like the first version, it kind of goes beyond the scope of the first exam in this quarter. So that's why I select some of the old midterm questions from the professor and see if they can like represent what we are doing right now. And since that the second version should be a better reference for you to predict
that's a relief.
Real exam will be. And of course, as I said, it's the lower bound because I only select a few questions. I do not select all the questions related to the first 3 chapters. So I would say it will be the lower bound of in terms of difficulty, but the actual exam won't be like too much harder than the version 2. It can be slightly harder, but I would say it won't be too hard. And it will definitely be much easier than the version 1.
And then for the words in 1, I understand how the number 3 is not concepts we've learned yet. what part of number 2 is exactly not going to be on the test per se?
It's
The corner
except,
part, right?
except for determining the corner solution. All the things
Okay.
are kind of standard.
Oh, okay. So the
Once
corner
it's interior
solution. Okay.
solution, if I told you that it's interior solution, you don't need to check if x should be 0 or y be 0. Just go through the standard procedure, writing out the Lagrangian, taking derivatives, and rearrange equations. All those are the same.
Okay, so we don't have to worry about the corner solutions for this
Yeah,
upcoming
and
test.
as I said, we even don't want to test you on quasi-linear utility function or perfect substitutes.
Yeah.
So
Okay.
just prioritize your time with the 2 types of utility functions that we discussed today, and kind of strategically skip quasi-linear and perfect substitutes.
Okay, and even then, for utility functions, only focus on solving for the interior solutions.
Yeah. As
Okay.
you can see today, we only solve for interior solution. Either point B or this point, it's both of them are positive, so we don't have corner solution.
Okay, but unlike the first slide, you were talking about how it can be a corner solution though, right?
The first slide, yeah, we kind of want to reassure that it's indeed interior.
Okay, but we don't have to know that when we're solving it.
You don't have to know that because we don't want you to show your knowledge about knowing that it's not in corner.
Okay, so it will be labeled clearly in the question, like, okay, interior solution.
It probably won't label it, but you should know that the solution is interior.
Okay, cool.
Just pretend that you don't know what corner is. So
Okay, cool.
It can only be interior, right?
Okay.
So you should just know at least, like, if you plug in 0 for x and y, if it's possible or not, or just completely not.
It's not possible, right? When you plug in 0.
Yeah, so that level, I guess we should know, right?
Yeah, that will be enough for the exam, I would say.
Also, so this goes up to utility maximization problem. It doesn't do compensated demand, like Hicksian demand.
No, that will be next week's topic.
Okay.
Yeah, the first week will be a very standard exam, the first one.
For full credit on the test question.
Sorry, the question?
For full credit on the test questions, how, like, do you want us to show how we differentiate like everything to get full credit, or do we just need to like know how to solve it basically?
You need to provide some calculation stats.
Okay.
And your answer should be right. So even your answer is not right, for example, if you have some calculation mistake, it's okay. You just get like 1 point off or 2 if your stats are correct. So show your work step by step. And even though you have some calculation mistake, in the middle even, we will treat it as given and then forget about the numbers you're writing, but just that the steps that you're writing. And then if you are using, a wrong number at the beginning all the way through it, we still won't double penalize you. We will look at your steps.
Okay, so like for example, when we were looking at the Cobb-Douglas utility, to get the full answer or to get the full credit, you would need to show like py times y equals 0.7 px x over 0.3. We wouldn't just need to know that it's 0.3 times I over p of x or over px.
So these
to like show everything.
These are the final answers. So these 2 are the final answers. So without giving you what px and py and I are, you just have these as your final answer. And
so we don't need to show the other stuff?
You have to show like these, at least the third equation here.
Yeah.
You don't have to show how you calculate each component, but you should at least show that in the middle of your calculation, you encounter this equation.
Okay.
And then you have some calculation steps that can finally lead you to these 2 answers.
Okay.
Yeah, and that would be all, I would say. So if you, for this question, the answers that will get full credit will be this plus maybe this and this and this. So 4 equations will give you the full credit.
Okay.
So definitely do not write a lot of things, just write the most important things. But when you are not sure what are the important things, you can write a little bit more, but not too
Okay.
much.
Okay, thank you.
You're welcome.
I have just one more question about the layout of the exam. Do you know how many questions there's going to be?
Depending on how long each question is. So if the question is very short, like if it is just one question mark, and if only asks you to write one sentence, there can be more of those kinds of questions. Or there can be one big questions with like multiple parts. So depending on how long the question is, but I would say there is a mix of short questions and long questions. So maybe 3 short questions or 2 long questions. I mean, 3 short questions and 2 long questions, or maybe 4 short questions and 1 long question, kind of like that.
Okay. All right.
And for long questions, there can be like 2 to 3 parts. So like part A, part B, part C, at most.
Okay.
I think slightly longer than the practice midterm part 1, version 2, but not too long. And I would say like some questions are fairly easy and straightforward, and you don't even need to write more than 1 sentence. So that's all I can say.
Okay.
Are you,
Thank you.
gonna put out like the full key for version 2 or no?
Oh no, because that's the like the original questions of the professor. So I already know like how to do question 3 and 4.
Yeah.
And for 1 and 2, they are kind of, I would say they're not too hard, and I don't see the need of posting them. And for 3 and 4, that's all the most I can give, not original answers, but like some hints for those 2 questions. And hopefully they are enough for you to understand those 2 questions. And also, because it's open note, you won't see like exactly the same questions in the actual exam. So I don't see any necessity of having the answer keys.
Okay.
But you can ask if you are still confused about any of the points that I made.
Okay.
Hi, I still have question about the quiz.
Who is asking?
Me.
Okay, Sherry. Okay, please ask.
So how many lectures gonna covered in this quiz?
So the coverage will be lectures 1 to 6. And
1 to 6, okay.
It's
the chapter is 1 to 3?
And for text chapters, it will be 1 to 3. And all the things I talked about up to this point. So some of the contents may not be covered by the professor. And you also need to take a look if I mention about them. Because the professor specifically asked me to cover the things that should be covered, but he does not mention. So that's why he may also test you on those things.
Thank you. How about like the solution for the practice exam? Like where can I find the solution?
It's under the files and AK to the practice midterm. And I already upload all the things I can upload. And for version 2, I can't give you the full answers. I give you some hints. And for the first one, I think it's just too hard. So I don't think it's very useful, except for question 1. So question 2 is about quasi-linear. You can take a look at how to get the optimal solution, but I think my TA slides will be enough.
Thank you.
And question 3 is totally beyond the scope. I think I would like to end the TA session now, otherwise it will be too long. And we do have an extra office hour this afternoon. So if you have more questions, you can ask then. All right? Okay.
All right.
So thank you for joining, and I will end this session.
Thank you.
And good luck. Bye.